Bismillahirrahmanirrahim. How are you, students? I'm your teacher Aftab Alam, and today we will study unit number 8, lecture number 31. Topic is waves. So, in this chapter, we first we will define waves, and then we will study periodic waves. So, we have to describe what is meant by wave motion, and we will explain different types of waves. So, first, waves, a traveling disturbance that carries energy through matter and space. Waves transfer energy without transferring matter. Waves are produced by smooth something that vibrates. So, waves is the disturbance of a medium. Waves is a disturbance of the medium. Disturbance that carries energy through matter and space is called waves. Waves transfer energy without transferring matter. So, waves are energy carrier. Waves are waves transfer disturbance from one place to another place. Now, waves definitions. A wave is something that carries energy through matter and space. Waves transfer energy. Energy is spread out as a wave motion. Most waves are caused by vibrating objects. What is medium? Is the matter that waves moves through. For example, water is a medium and air is a medium. So, even the earth can be a medium. Now, what is a periodic wave? A periodic wave is a wave. Periodic waves are waves that repeat itself. Any wave which repeats itself is called periodic waves. Here, vertical position of wave is shown. This is the vertical position. This is the horizontal position. Now, in this case, the wavelength is start from this point, one crest, one trough. The region below the mean level, the mean position. This is called crest. This is called crest. This is called crest. This is trough. This is trough. This is trough. So the distance in which consists of one crest and one trough is called a wavelength, and the time required per one wavelength, per one cycle, per one vibration, per one revolution, per one rotation is called time period. So amplitude is represented by A, and it is the maximum disturbance, the maximum displacement. So amplitude, this, if you take a wave like this is called amplitude. This distance is called amplitude. Wavelength is the distance which consists of one crest and one trough. For example, if this is crest and this is trough, this distance is called one wavelength. It's called a wavelength. The reciprocal of time period is called frequency. The unit of time period is second, and the unit of frequency is per second, and per second is equal to hertz. Now, wave speed is what? Wave speed is the product of wavelength and frequency. So v is equal to f lambda. V is equal to f lambda. So we studied that frequency is the number of vibration completed in 1 second. Number of vibration completed in 1 second. If 10 vibration is completed in 1 second, the frequency is 10. 10 vibration completed in 1 second in a time of 1 second. So frequency is 10. If 5000 vibration is completed in a time of 1 second, frequency will be 5000. And the time for one vibration is called time period. In this diagram, this is the wavelength. This is the wavelength. This is crest. This is crest, this is trapper. Now if we shake a string, a stretched string, once a wave pulse will travel along the string, but afterward the string returns to its flat equilibrium position. If instead we attach the string to a simple harmonic oscillator, mass attached to a spring is simple harmonic oscillator, we will produce a periodic wave. A simple wave is sinusoidal wave. For example, it vibrates to and fro. So the string will feel like this. This type of vibration is produced. The simple harmonic motion of the spring and mass generates a sinusoidal wave in the string. Earth particle in the string exhibit the same harmonic motion as the spring and mass. The amplitude of the wave is the amplitude of its motion. So the mass attached to a spring is simple harmonic, so this will be also simple harmonic motion. Periodic waves. We already discussed any wave which repeats itself after regular interval of time is called periodic wave. Now, periodic waves are produced in the ripple tank. A more effective demonstration of periodic oscillating source is provided by an electromagnetic vibrator in the ripple tank. An oscillating mass spring system is periodic waves. Now, what is progressive wave? What is progressive wave? Any wave which is periodic in nature, periodic in nature, repeat itself after equal interval of time, which traveling away from the source, is called periodic wave. For example, progressive wave distribute energy from a point source to a surrounding area. The move energy in the form of vibrating particles or field. For example, if disturbance is produced, and it is spread in all direction, so here is the source, and the disturbance is traveling in all direction. This is called progressive wave, because disturbance is produced in the middle and traveling from the midpoint. So this is called progressive wave. If a string is stretched, if you take a string and give an up and down jerk, source is here, disturbance is traveling away, so it is called progressive wave. Now, progressive waves move energy from one place to another. In a progressive wave, the wavefront move through the medium. There are two types of progressive waves: transverse and longitudinal. Transverse waves are waves where the displacement of the particle in the medium is perpendicular to the direction of the wave is traveling. In longitudinal waves, the particle movement and the direction of propagation of waves is parallel. For example, if we want to decide the nature of a particle, the nature of the wave, whether it is longitudinal or transverse, we have to decide two things. First, particle motion, wave direction of wave motion. Now, if particle is propagating in this direction, wave is propagating in this direction, this is par transverse, this is par longitudinal, and the particle is vibrating perpendicular to a direction of propagation, then the wave is called longitudinal. And if the particle is vibrating parallel to a direction of propagation of wave, the wave is longitudinal. The wave is longitudinal. Now, wave types of waves. Waves are divided into two categories: mechanical waves, electromagnetic waves. Mechanical waves and electromagnetic wave. Mechanical waves are further divided into longitudinal and transverse. Example of longitudinal waves is sound waves, and transverse waves produced in the water. Waves produced in the water. So water waves are longitudinal, transverse. Sound waves are longitudinal. Mechanical waves require medium for their propagation. Electromagnetic wave does not require medium for their propagation. Light wave, micro-oven waves produced in micro-oven, X-rays, ultraviolet rays, radio waves. All these are electromagnetic waves. So mechanical waves need medium for their propagation. Longitudinal transverse waves are the types of mechanical waves. Now, classification of waves. Transverse waves and longitudinal waves are classified as progressive waves. Progressive waves transfer energy from one place to another place. Now here you can see in the diagram transverse waves. The waves propagate in the direction perpendicular to direction of vibration of particles. The wave propagate in the form of crest and trough. This is called crest and this region is called trough. So particle is vibrating perpendicularly and wave is propagating in this direction. So it move up and down and disturbances transfer in this direction. So transverse waves. What are longitudinal waves? Longitudinal waves propagate parallel to direction of propagation of waves. Sound waves, the primary waves of earthquake, ultrasound waves, vibration in a spring. Mass attached to a spring is transverse or longitudinal. It is up to you how you are dealing and the way you explain. Now if you look here, in longitudinal wave, the displacement of the particle is parallel to direction of propagation, to a direction of wave propagation. What you see in the picture of the wave front progressing forward of the particle compressing and expanding in the same direction. Now the kind of wave is marked by periodic compression zone and rarefaction zone where the medium expands. Example of longitudinal waves, we already discussed this one, comes to next. Amplitude is the maximum displacement of a particle in a wave from its equilibrium position. This is amplitude. This is amplitude. Example of transverse waves. Waves produced in the ripple tank. Secondary waves of an earthquake. Electromagnetic waves. The waves on a string. Stadium human wave. The oceanic waves. Different types of waves. Characteristic of waves. Crest and trough. Crest, high points of the medium. These points are called high point. These points are called high points. Trough, low points. Crest is the highest part of the wave. The horizontal distance between the crest is the wavelength. For example, this is the wavelength. This is the wavelength. This is also the wavelength. This distance is also the wavelength. Frequency. Waves are also measured by their frequency. The number of waves that pass a point in certain amount of time. Trough is the lowest part of wave. The vertical distance from the crest to the trough is the wave height. Amplitude. Now look students, we will revise this and then we will explain it further. First we explain that wave is the disturbance in a medium. Waves carry energy. Waves transfer energy without transferring crest and different things. Wave motion is the mechanism by which disturbance is transferred from one place to another place. Wave motion is the mechanism by which disturbance is transferred. Periodic wave, which repeats itself after a regular interval of time, is called periodic waves. Amplitude is the maximum displacement from equilibrium position. Is the maximum displacement from equilibrium position. Frequency is the reciprocal of time period. Is the reciprocal of the time period. The unit of time period is second, and the unit of frequency is per second, which is equal to 1 hertz. Or time period can be frequency. Periodic waves can be defined as the wave which repeats itself after regular interval of time. The necessary condition for wave motion is a necessary condition for wave motion. Condition for wave motion. This is very important from paper point of view. Since the propagation of waves occur by the interaction of the particles of the medium, so the following conditions are necessary for the propagation of wave. First condition is the medium must be elastic. The medium must be elastic. The medium must be elastic. The particles of the medium should not be independent of each other, so they to exert force on each other. Transverse and longitudinal waves can be set up in solids. In fluids, however, transverse waves die out very quickly and usually cannot be produced. So the first condition is the medium must be elastic and the particle of the medium should not be independent of each other. Medium must be elastic. And the second condition is the particle of the medium should not be independent of each other. Particle of the medium should not be independent of each other. I will write the second condition. Particle of the medium should not be independent of independent. Transverse waves, in which the particle vibrate perpendicular to direction of propagation of wave. Transverse waves, in which the particle of the medium vibrate parallel to direction of propagation of wave. For example, particles wave propagate in this direction. Particle also propagate in the same direction. So the motion is longitudinal, and in transverse, wave is propagating perpendicular to direction of propagation of particles. progressive waves traveling, the waves traveling from the source is called progressive waves. Mechanical waves, electromagnetic waves, these are types of waves. Mechanical is further divided into two types: longitudinal waves, transverse waves. Sound waves are the example of longitudinal, and this is the example of this sound. Water waves are the example of transverse waves. Transverse waves propagate in direction perpendicular to direction of propagation of waves, longitudinal waves. Now I will explain an equation. The equation for you should memorize this equation: V is equal to under root T cross L divided by M. In next coming classes we will do the derivation, but remember the velocity can be calculated with this equation also. You can find the velocity by T under root M. Velocity is equal to under root T by M. I will write again. T is equal to under root T divided by small m. V is equal to T divided by M. This is V. Frequency of waves. The number of waves passing through a certain point in unit time is called frequency. Intensity of wave. Intensity of wave is the amount of energy transmitted per second per unit area perpendicular to direction of propagation of waves. Energy transmitted per second per unit area. Energy transmitted per second per unit area. Energy transmitted per second per unit area held perpendicular to direction of propagation of wave is called electric intensity of wave. Power exerted per unit area is called intensity of wave. Now, next coming topic is sound, but I will explain only 2 points. Speed of sound. We have to calculate the next coming topic, speed of sound. Speed of sound depends upon the two characteristics of medium. First, density of sound medium. Density of the medium. Density of the medium and elasticity of the medium. Elasticity of the medium. So remember this equation. The speed of sound depends on two factors: elasticity of the medium and density of the medium. So it is equal to E divided by rho, where E is the elastic modulus of the medium and rho is the density. Rho is the density. Thank you, students. Wish you best of luck. Allah Hafiz.